All right, this is Miss McGee, and I'm going to talk to you about absolute value inequalities for just a minute. So inequalities means I'm dealing with a less than or a greater than sign. So maybe I have something that looks like absolute value of x minus 1 is greater than or equal to 2. So the first thing you want to do is make sure that always, and in this case it is, but you want to make sure that your absolute value is isolated. And what I mean by isolated is make sure it's by itself. Okay, so maybe if there was, and let me finish, absolute value. Maybe if there was a, say, 2 in front of this absolute value, I would need to divide both signs by 2 before I started, and then I'd be ready to solve. So we're going to start a little easy, and this one is already isolated for us, so we're good to go. So I'm going to teach you a little trick when you solve these. When you have your absolute values expression written on the left side, we look at this sign, okay, the greater than or less than sign. If that sign is greater than, like it is here, then we use a little trick. We write greater, we kind of spell it wrong there, great or than, to indicate that this is going to break up into an or compound inequality. So to do that, what I do is I take what's in the middle, which is x minus 1, and I basically write it exactly the way it is right now, but I drop the absolute value signs. But then what I'm going to do is I'm going to write the word or. I'm going to do it again, but this time I'm going to flip both the inequality sign and the sign of the number that follows. Well, now these are pretty easy to solve because they are linear inequalities, and I can just solve each one for x. So I can add 1, and then I can say or, and I can add 1 here and get x is less than or equal to -1. So this is the algebraic solution. If I were to do the graphic solution, then I would just take my number line, and I'm going to come over here to the side so that you can see. Here's my number line. I would have, here's -1, so I have 0, 1, and here will be 2. So if you recall, an absolute value inequality goes off in both directions. Because this is inclusive, this line under here means inclusive, I'm going to put a closed dot at each one of these. If this was just greater than and just less than, then you wouldn't need the dot. It would be an open dot, not a filled-in dot. Greater than, x is greater than or equal to 2, so the numbers get bigger this way. And then, of course, the numbers get smaller for the less than or equal to the left. So that's a greater than inequality. So let's look at one that's not greater than. Let's look at one that maybe is less than. Let's say, and in fact, we can, well, we'll change it up a little bit. Let's do the absolute value of 2x plus 3. This time, instead of being greater than, I'm going to do is less than, let's say, 5. Okay? So now I'm looking at this sign, and the little trick, the little mnemonic trick to this is we think, and remember this works because the absolute value is on the left. We write that first. But this is less than, so we kind of misspelled this one again, and we set up an and, okay? So what we're going to do, and is set up a little bit differently. It's a little bit harder to set up, but it's not too bad. We take the number that's on the end and change the sign, okay? And then we're going to do less than. We take what was in the absolute value sign. And so we're kind of sandwiching this between, and then I am going to write the same number again. So we're kind of sandwiching it between the opposite and the same sign. So now when we solve this, instead of it being just one piece, what we have to do is we're going to, when we isolate x here in the middle, we're going to have to subtract 3, not just from 2 sides, but all 3 sides now. So now I have -8. This is canceled out, and I have 2. And so now I'm going to divide by 2, and I get -4 and 1. So again, on the number line, as I look at this, start here at -4, then I got 3, 2, 1, 0, and here is 1. This one is less than, it's not, or equal to, so it's not inclusive, so I need an open dot at these. And because the X is sandwiched in the middle, that tells me that I shade in the middle here. It's an and, which this is what an and looks like. So that's graphically. Now, I want to show you just one at least where we do have to do some work to isolate that absolute value, and then we'll solve it. If I had, let's say 1/2 times the absolute value of x minus 3 plus 5. Let's do greater than 7. Okay. In this case, my absolute value is not completely by itself, so I need to make sure I get it completely by itself. So what I want to do in order to do that is I want to kind of work backwards using my backwards order of operations to solve. So I'm going to move the 5 first, and then what I want to do is get rid of that 1/2. So if you recall, as we're solving equations or inequalities, we never want to divide by a fraction. Rather than dividing by a fraction, what we really want to do is multiply by the reciprocal, because that's going to cause that to cancel, and what we do to one side, of course, we have to do to the other. So now I have the absolute value of x minus 3 is greater than 4. So if we think back to where we just talked about, remember we said greater than, great or than, is an or inequality, and that's greater than or equal to, and less than or equal to is an and inequality. So this one clearly falls under the or category, so I want to set that up. So I'm going to do my 2 separate. One, I'm going to write it just as it is. And then I want to do or, and I want to write it, but I want to flip the inequality sign and flip the sign of the number. And now I'm all set to solve. Add 3 to both sides here. I've got x is greater than 7. Or add 3 here, and I have x is less than -1. A couple things to watch out for here, and I will graph this one for you over here on the side. If this is -1, 0, 1, 2, 3, 4, 5, 6, 7, I'm running out of room here. We'll just do the open dots on each one, and again it's or, so it's going off in either direction. What I want to mention is be very careful, because there will be times where maybe you have something that you get, and whenever you plug the solution back in, it doesn't work. That's what we call extraneous, and so you need to check for those. Additionally, if you have something that looks like this, an absolute value is never going to be negative. It can't by definition be negative, so we would say that this has no solutions here.